Simplify the fractional expression. Expressions like this arise in calculus. And this following expression is not only a fractional expression, it can also be called a rational expression. And when it talks about expressions like this arising in calculus, it actually arises in just about every branch of mathematics. And so what we really need to understand is the technique for simplifying this. These kind of expressions will occur in derivatives and integrals alike in calculus. You may have to simplify an expression like this in a differential equations course. So first off, let's start by understanding that I need to go ahead and expand out each component in this particular expression. And I'm going to start with the x plus h quantity cubed. Remembering that x plus h quantity cubed is the same thing as saying x plus h times x plus h times x plus h. And then I can go ahead and apply the FOIL method to the first two factors and then multiply using the distributive property that third factor across the resultant product between the first two factors. Instead, what I'm going to do is use the binomial theorem and understand that the following formula, a plus b quantity cubed, is actually going to allow me to easily multiply this out. And a plus b quantity cubed is simply equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. And so in this instance, x will replace a and h will replace b. And what I end up with is the following. Next, I want to look at the second component here, which is going to be this right here. And what I'll do is I'll distribute -7 across the parentheses and multiply it by the x and the h terms in that binomial. And I end up with -7x minus 7h. And then finally, I'll look at this third term, and I will distribute this negative sign, which is in reality just a -1, across both terms in this binomial. And so negative quantity x cubed minus 7x is simply equal to -x cubed plus 7x. Now notice that the h in the denominator hasn't changed at this point. And so we're going to leave that alone. And we're going to go ahead and add in all our components here. We're going to start with the x cubed plus 3x squared h plus 3xh squared plus h cubed. Then we're going to subtract 7x and 7h because that's our second expression. And then finally, we'll finish up with a -x to the third plus 7x. Now that I've done this, what I want to do is go ahead and combine like terms, if at all possible. And so we'll look at this and we'll see that x cubed here will add with -x cubed to give me 0, so they add out. And then I'll look and I'll see that I have a -7x here. And that will add with positive 7x to give me 0. One of the things that you notice is the remaining four terms all have an h component in them. And so we end up with this being 3x squared h plus 3xh squared plus h cubed minus 7h. And that's all over h. So now what we're going to do is understand that this right here is a common denominator. And if that's the case, that means that I can actually rewrite this expression in terms of four fractions. I'll have 3x squared h over h plus 3xh squared over h plus h cubed over h minus 7h over h. And then you'll notice that since there is a common factor in both numerator and denominator of each one of these fractions, I can go ahead and simplify by dividing out said common factor. So h will divide out here and here in the first fraction, leaving me with 3x squared. In the second fraction, since I have h squared here, h will divide out once, and will divide into h squared h times, leaving me with 3xh. And then in the third fraction, h will divide out in the denominator, and then if I divide h cubed by h, I end up with h squared. And then you'll notice that h here divides out, and I'm left simply with -7. And that's my resultant answer. And there's nothing else that I can do with that.